In question 13, we have a fairly complicated scenario. We have a museum that has decided to sell one of its paintings and then invest the money it gets back, the proceeds. What we have is a window where the picture can be sold, somewhere between the year 2000 and the year 2020. If the money from the sale is invested, then the museum can earn 5% interest per year, a little optimistic currently, but that's fine, compounded annually. So that's going to go back to our first week material where we looked at how to build expressions for compounding. And to compare scenarios fairly, what we're going to do is look at how much money would the bank have in a fixed year, the year 2020, depending on when the painting is sold. What's not quite clear right now, of course, as with any volatile instrument like a painting or a stock, is we don't know what the price is going to be during that 20-year window. Whenever we can sell it, we don't know exactly what the price is going to be in the future. To capture that, we're going to say there's a function that we may or may not know, that P of t is going to be the price a painting will sell at if it's sold in year t. What we're interested in is a related quantity to that, which is B of t, which is the balance for the museum after interest in 2020, which depends again on the sale year t. We're going to call t equals 0 the year 2000, so we have t being between 0 and 20, and what we're going to claim is that this price of sale here is going to be multiplied by this other thing here to get the amount of money in the bank account of the museum from that sale, and we really need to break that down. What we're going to get from this is an idea of a 20-year time horizon, and imagine first graphing P of t. What that is some price of the painting that might grow up quickly, might even go down at other points, like here. The idea is if you want to sell at 10 years, this is the price you're going to get for it at that point, at that 10-year mark. If you sold it after 3 years, this would be the price you would get. Now with most instruments, most things like paintings and stocks and such, on average, the price of it is going to go up over time. So it seems like a no-brainer to say, well, I should just sell at the 20-year mark by default. However, there's an advantage to selling early, because if you sell early, you actually get interest on the amount that you have in your bank account from the sale. And that's what this other factor here is. This is the sale price. But this other ingredient here is the interest we get. And if you think about a 3-year sale, we sell it after 3 years, the painting. How much time do we have left to gain interest? Well, we're going to have 17 years of interest that we can build off of that. Notice how do we get that 17? Well, if I sell in year 3 and I'm comparing everything after 20 years, then the difference is 17 years, and that's what's hiding in this 20 minus t formula inside our total value calculation. So the money in our bank account at 2020, or in 2020, is going to be determined by how much we sell the item for, how much we sell the painting for, at whatever year we pick. We can pick any year we like. But the longer we wait, the bigger t is. So if we sell after 10 years, we only get 10 years of interest. If we sold after 19 years, we might get a little more money, but we're going to get a lot less interest. And again, there's going to be one of these trade-offs between the value of the painting when we sell it and how quickly that goes up versus the amount of time we have left afterwards to gain interest. Why is it this particular formula? Well, because we have 5% per year and it's compounded annually, we're always getting our 100%, what we started with, plus 5% to the power of the number of years that we're investing for. And so when we use 20 minus t, that tells us how long we're going to be investing our sale price for. In part B and C, we're looking at a particular scenario. Part C has the scenario itself. Part B is just a quick decoupling of this to make it a little easier to work with in terms of calculus. This formula here can be rewritten if we want to as P of t again times 1.05, and if we have this difference of powers, that's the same as 1.05 to the power 20 times 1.05 to the power negative t. Because we know if we have two bases that are the same, we would add the exponents and we'd have 20 minus t. That's what we have. And if we want to, that negative t power can be brought to a denominator, so we could rewrite b of t like this. Let's try that. If we want b prime of t, notice that this factor out here is just a constant. It's 1.05 to the power 20. Then here we have two factors with t in it, and they're in a ratio, so a quotient. So we're going to have to take the derivative of the top times the bottom minus the top times the derivative of the bottom, which is, it's an exponential with a base 1.05. So we get the same exponential back times the ln of 1.05, all of that over the bottom all squared. And that would be our derivative calculation, and then we're given enough information. The price, remember the 10 here would be 10 years. If we're selling the painting after 10 years, we would make $150,000 from the sale. That's what that's telling us. If we sell it 10 years, we'll make $150,000. And then this formula tells us we'll have 10 more years to get interest because we have a 20-year time horizon. We're also told this other rate of change, which is at the 10-year mark, the price of the painting is increasing. And because this is a derivative with respect to time, we can interpret this as increasing at $5,000 per year. Maybe not for a long time, but because it's a derivative, at least in the short term, we can estimate that the price of the painting after 10 years would be increasing at $5,000 per year. How does that help us? Well, it helps us fill in some of the blanks. There's our derivative, there's our value, and everything else is pretty much stuff that we know. So we can start filling in the blanks to get b prime at time 10. b prime of 10 will equal 1.05 to the power 20 times the p prime, so how much more do we get per year after a sale, times 1.05, and we're going to use t equals 10, minus how much if we sell it for now, 150,000, p of t, 1.05 to the power 10, times the ln of 1.05, all of that over 1.05 to the t all squared is the same as 2t, or over 20 when we're using t equals 10. And just a quick scan of that gives us a little cancellation we can do. There we go. In the end, we obtain a value of negative 3,776.63. Now, what are the units of that to help express this? Remember that this is t inside, this is time, but this derivative is the rate of change of b, and b is in dollars in the account, in the bank, at 2020, divided by t in years after our sale price here, after t equals 10. So for each year we wait that we sell, let's add that in here, that we sell at. So what this is telling us, on the next page is the question, decide whether the museum should sell or keep the painting at 2010. This statement here is telling us that if we were to wait one more year to sell, that's changing t from t equals 10 to t equals 11, we would expect when we look at the bank balance in 2020 that we'll have fewer dollars, about $3,700 fewer than if we sold right now. Because that value b prime is negative, and b is the comparison of, or b prime is the comparison of the amount in the bank in 2020 divided by, or the rate of change with years, the year of the sale. As soon as this is negative, it means that if we wait, which means increasing the year of the sale, or t of the sale, it's going to result in a decrease in the amount in the bank. That's AMT, amount in the bank, at 2020. And so the bank should sell, or the museum should sell now. If they've already gotten to 2010 and they're in this scenario, if they wait longer, they're going to end up with less money at the end of our period than if they just sell right now. For those who have studied a little bit of economics, this is a classic future value problem, where we can take an action, here it's the selling of the painting, at a variety of times, but to compare apples to apples, we ask, what would the value of that action be at some specific future date? Here's the year 2020, so that we can compare a sale after 1 year with a sale after 10 years or 15 years in some kind of measured way. And the important thing we have to include in that is the idea that an early sale can then gain more interest, which is beneficial to us.